In that case, thank you, Hadi, and welcome to this programming tutorial today, in which we're going to make a little GUI application, which I'll show you in a second. And we're going to be doing this primarily in functional style. Now, Kotlin is not a pure functional language like Haskell or Camel, but it does have all kinds of support for different things and patterns that you see in functional programming languages. This tutorial does not assume you are already familiar with Kotlin. This is not a general Kotlin tutorial either, though. I will be pointing out things which aren't really obvious from the syntax as we go, and you can ask any questions about anything you didn't understand in the Q&A section. There are people who are familiar with Kotlin ready to answer any general questions you might have. So this is the app that we're going to build today. It is implementing a kind of type ahead that you're familiar with from JetBrains IntelliJ products. So for example, you can type like this, and we're doing auto-completion over English text. Okay, that's the algorithm we're going to implement along with the user interface. This application is loading its data from this simple tab-separated file. It's very long. This is a file of NGrams, which I've downloaded from the free data set available at ngrams.info. And it's quite large. You can see there's about 3 million words, 3 million lines, sorry. All right, so let's get started. Are there any questions before we begin about what we're going to be building? I guess not.
I think we're all good.
Okay, great. So, if everyone can see that, let's enter distraction-free mode. This is going to be a JavaFX application. And JavaFX is the third generation UI toolkit that comes with Java 8. If you've ever done Java GUI programming before, you've probably used Swing. And Swing is the second generation toolkit, and it's fine. The JavaFX is a lot more advanced, and that's the one we're going to be using today. We'll be targeting Java 8U60 in this. Now, a stage is what, sorry, I went a bit ahead. This is what we started with. A stage is what JavaFX calls a window. If we try and show it, this is the first thing in Kotlin that is not entirely obvious from the syntax. This question mark here denotes a potentially nullable type, right? So we're getting a compiler error here because one of Kotlin's primary features is that it helps you tame null pointer exceptions by integrating optionality with the type system itself. So here the compiler is flagging that we might get a crash at this point if stage was null. Now, as it happens, I happen to know just from reading the documentation and so on that stage will never be null here. And because we're overriding something from Java, IntelliJ was conservative when it filled out this type signature. I can just delete the question mark here to tell the compiler this will never be null, and it will allow me to go ahead and use it like that. Down here, we're going to launch the app like that. This star operator here is a spread operator. We've got an array of strings from the arguments, and the application.launch method, which is a JavaFX thing, requires variable argument lists. So we're just doing a bit of a glue there. All right. In Kotlin, you can define local variables in two ways, val or var. A val is a value. It means it's immutable. It's like a final variable in Java. And we're going to have in our UI two things, as you saw. We're going to have a list view of completions and an edit field. And then we're going to pack them vertically. JavaFX comes with a GUI builder tool called Scene Builder, but it's not worth using for such a trivial user interface as what we're doing today, right? And it's going to be very trivial because we want to focus on the algorithms, really. A scene is the root of a widget graph. Okay, so let's launch this and see what we've got. Yeah, so we can see we've got the basics here. This is looking pretty packed. It's not looking like the app we had before. We can fix this by doing something like that. You'll see here that this is actually, although it looks like we're assigning to a variable here, actually behind the scenes, what's being generated at the bytecode level is called the set spacing method, right? Kotlin has converted get and set methods on this Java object into a property. But typing vbox dot vbox dot vbox dot is a bit annoying. So there's a better way, which is to use this technique. We say apply, like that. And what apply does is it takes this code block here and it runs it as if it was in the context of code inside this class, and then it returns this class. So this looks like a language feature. It's actually not. We can navigate using the IDE to discover what this really is. This is called an extension function. It's effectively a kind of syntax sugar for static methods behind the scenes, but in this case, we've defined a method here, this is actually in the standard library, I should say, that can apply to any expression at all. And what it does is it takes a function, it runs it in the context of that expression, and then it returns that expression. Very simple. And now, this is we can really see this is looking less like code and more like a declarative way of defining the UI, and now we have what we need. Okay, great. Well, this isn't really what we're all about, of course. What we want to do is some functional algorithms work. So let's get started with that. Now, the first thing we're going to do is define what an NGram is. An NGram is a set of words. Well, we'll actually keep it in memory as a single string, and a frequency, which we'll define to be -1, just by default, just for convenience purposes. A data class is a regular class which has some restrictions on it, and in return for obeying those restrictions, the Kotlin compiler will generate all kinds of useful stuff for us. If you've ever, really wondered why you're wasting your life defining builders and immutable classes and so on in Java, what this single line of code does, defines an immutable class, one that cannot be changed directly, with 2 fields, words and frec. It also defines equals, hash code, toString, and a few other useful bits and bobs. For example, a copy method that we can use to generate modified versions of this class, of these objects without modifying the original version. And for our needs, we want it to be comparable because we're going to put it into a sorted set in memory. So we're going to want to be able to compare these. We're going to start by ordering by words, and then if we've got a match, or if we don't have any frequency data, we'll just return that. Otherwise, if they're identical, we'll just sort by frequency. Okay. Now, we're trying to do modern development here. So we're going to start with test. We're going to do some test-driven developments. And because writing out unit tests is really boring and you wouldn't learn anything, I'm just going to auto-type this so we can see what we're actually going to implement. You know what? There's a strange IDE issue here, but if we do this, then it will recognize that these are unit tests and allow us to run them. And this one we haven't implemented yet, so we're going to do that later. So we can see that we start out by defining a little test data set with a few phrases that have common prefixes and so on, some fake frequency data. And then we've got a few unit tests down here where we're going to try and turn a string like WELTM into a disambiguated match against welcome to my, as opposed to welcome to the. Okay. And ngrams here is a tree set which doesn't have a complete method. So we're going to create our own extension method at this point. We could, of course, subclass tree set, but for reasons that will become apparent later, we're not going to do that. And we're going to take an input. We'll return a list of completions. And we only want this to apply not to any navigable set, but only to sets of ngrams. And we'll start by returning an empty list. Okay, so this code will now compile, but of course, if we run it, then what we're going to see is that the tests are not going to pass, right? Which is what we expect. Okay. Now, how are we going to implement this algorithm? And I should stress at this point that this is not the same algorithm that IntelliJ itself uses. This is a one intended for English text, and it's not the best algorithm you could use. It's intended to be short enough that we can fit it inside 45 minutes, and that's about it. Okay, so don't criticize my autocomplete through, please. Okay, so we're going to start by converting the input into a sequence of pairs of all possible prefixes and suffixes. So it can be a little hard to visualize what we're doing here. Let's say input is avect. What we're going to turn this into is a pair of that, like that. I think you get the idea, right? We're going to start by just making this to lowercase. And now what we're going to do is start with a lazy sequence. A sequence is what Kotlin calls a lazy list. A lazy list is like a regular list, except the items in it are not evaluated until you access them, and as a result, it's possible for the lists to actually be infinite in size. Building lazy lists and lazy sequences is something that you do pretty frequently in languages like Haskell. You do it much less commonly in languages like Kotlin, but it's still there if you want it, and we're going to do this right now. Now, we're going to start with an integer lazy sequence that goes from, in this case, imagine this is our input example. It's going to go from 6 down to 0, and that doesn't get us very much. But what we can do is apply a map to this. A map is what's referred to as a higher order function. Again, this is an extension function, and what it does is it applies the transformation that you provide to every item in this lazy sequence, but again, because it's all lazy, it won't actually do anything the moment we run this function. It'll just store it up for later. So let's take some substring, and we'll take that. Okay, so what this is doing is it's mapping this sequence of numbers to these pairs of strings. The to method here, again, this looks like language syntax, but it's really not. This is yet another generic extension method. You can call to on literally any expression. You give it a single parameter, and it gives you back a pair, which is a well-known concept from, I think, every programming language. Behind the scenes, of course, it's just a regular method like that, but Kotlin allows us to use infix notation with it, just to make it, the code look a bit nicer. So far, this hasn't really bought us anything. Doing this stuff in the functional style hasn't really helped us in any way. It's just made things a little less clear, even perhaps. But we'll see the benefit in a second. Now what we're going to do is define another extension function, this time a local one. So it's only valid in the scope of complete. And this is going to be a one-liner. And Kotlin has very lean syntax. It has an emphasis on very lean, minimal syntax when you don't need it, as long as it's still readable, of course. It's not quite as terse as Haskell. What this is going to do is we're going to do a prefix scan over the navigable set. So we're going to select all of the items after, we have, of course, a set of NGrams here, all of the items after the input, and then all of the items before the input plus the maximum possible character. So this is selecting all the items in the set that start with that prefix. And now what we're going to do is do another map. Again, a lazy map. Nothing is going to be calculated yet. And once again, we're going to map this set of pairs to another set of pairs. Now, at this point, what do we have actually in queried? What we've got is something like this. We're going to start with avvect, and there's nothing that has this prefix in our set, so there'll be no query results. But there's also no disambiguation characters. Then we're going to try avvec with one disambiguation character, t. But again, there's nothing that starts with avvec, so we'll have another like that. And then finally, we'll try avve, and there's 3 like that. So we'll get very common thing, and the rest, and it'll map to CT, and so on. Now, eventually, we'll have the entire set, because we'll do an empty query, and everything will be the disambiguation character. But because this is lazy, ideally, we never actually evaluate this last thing. We never do that query. We never end up trying to query the entire data set at once. Okay, is this clear so far, what we're doing? If you've got any questions, please do the webinar equivalent of shouting them out. Now, we only want the first one.
No questions so far.
Okay, that's great. So we only want the most specific match. So we only want this one, and we don't want to even evaluate the latter. We don't want to even run the code to calculate them. So we're just going to drop items while the first one is empty. There we go. So we're going to get rid of these 2 and leave this one behind. And then what we're going to do is destructure, because remember this is a set of pairs. We're going to split that pair into 2 variables called candidates and remaining. And we're going to just grab the first. And there will always be at least one, because we will at some point do a query with the empty string, which will match the entire set. And this destructuring support is possible because of this data class thing up here. If we search for pair, as defined in Kotlin, we can see this is also defined as a data class with just 2 values, and it customizes a toString. Otherwise, the compiler would generate one. And one of the things that the data keyword does is it generates a set of methods called component 1, component 2, component 3, component 4. Here we go. So there are these 2 component methods, and when we use this syntax here, the compiler will generate calls to these methods behind the scenes. Those don't have to be generated by the compiler. We could have written them ourselves, but in this case, they were generated for us. All right. So let's just see how far we've got, and let's just return. We can't return candidates directly because what we've got here is a list of NGrams, and what we said we would return as a list of words, right? So now let's see how far we've got. Okay, well, it's failing as we expect, but now for a different reason. We've actually got a bit further. We did in fact match welcome to my based on this input string, but we also matched welcome to the because we're not using the final characters to figure out which one we need. Okay, so it's working as we expect so far. That's pretty good. Now what we need to do is we're going to define a function to break down a string into a set of pairs like this. Hello will turn into HE, EL, and so on. This will be another extension function. Down here, we'll return a list of strings. Oops. Let's put this bit of code up at the top. This can actually be expressed in a single line. So let's use a short form. And let's use, this time instead of a map, which applies the function to every element in a list, we're going to use map indexed. And map on a string applies the given function to every character. And map indexed applies the given function to every character with 2 arguments, the index and the character itself, which is exactly what we need here. Now what we're going to do is say, you know, if we're not right at the end, then we're going to generate this pair. We're going to do this using string interpolation here. So we're going to take the current character and then the next one. Or if we would have run off the end, we'll just generate the empty string. This is getting a bit wide, but because this function is just local, we don't actually need that return type. The compiler will figure it out for us. This will generate the characters we want, but it will also generate this empty string at the end, which isn't quite what we want. So we'll tell it to just drop the last one. And now let's see, does this do what we expect? Yes, it does. So you'll notice that so far, all the code we've written is in a functional style. Although we have what look like variables, these are actually just named expressions, really. The compiler is free to do what it wants with them because they cannot change. Oops, not chair pairs, car pairs. Is going to be, it can be that we've only got a single disambiguation character. Now I should point out that I'm using M14 Kotlin here. If you upgrade to Kotlin 1.0, which came, 1.0 beta, which came out today, the length has become a property, so you wouldn't have the brackets there. If we've only got a single disambiguation character, this code is a bit messy here because we've got this thing that claims to be character pairs, but actually doesn't always the case. But if we have more than one disambiguation character early, and then we're going to take whatever's left. I get a prefix like that. And now what we need to do is restrict the candidates we have here using these disambiguation characters. So we're going to do a filter. And a functional filter is a very simple thing again. There's nothing magical about functional programming. A lot of it boils down to simple functions and syntax sugar for certain ways of thinking, in my view. And we're going to start with a filter which takes a given function. Again, this is a higher order function which takes another function as an argument. And it will return a list for which the given function returned true. So we're just using this to drop anything we're not interested in. So here we're going to take the candidate, which I've renamed. You don't actually need this in Kotlin. If I didn't have this, I'd be able to access the candidate using this default name it. But sometimes that's what we want, like here. But other times it's more convenient if we rename it. And if there's more than one argument, you have to give names. So we're going to take the postfix here of the candidate. And then we're going to do another map over each character pair we have. And again, we'll give it a name because we've got nested functions here, so it could get a bit confusing. When our pair is not really a pair, this is again the messiness that I'm tolerating because this is a tutorial, then we'll just do a simple scan to see if the remaining disambiguation character appears anywhere. Pretty simple. Otherwise, we will ensure that the pair appears in order. This let function here, well, you know what, I'll finish typing until the redness goes away and then I'll go back and take a look. It's not happy because filter expects a Boolean, and the last expression here is still not a Boolean, it's actually a map. What this is going to do is give us an array of Booleans for each pair of disambiguation characters, right? CT or ECCT. And we only want the word to match if all of them are true. And we've got here as a list, and what we want to do is convert it into a Boolean. And what we'll say is like, answer this question for us. Do all of the elements match this predicate? And because it's a set of Booleans, the predicate is the identity function. We can pull up the documentation here to see what this is doing. And it's very simple. So here we turn our list of Booleans into a single Boolean. And then finally, it's still not happy because the interface this function is a set of strings, and what we've actually got here is a set of NGrams, so we've got frequency data that we're not returning to the caller. So let's sort using the frequency data, and then let's get rid of it by selecting just the words. And now we're done. Now I said here that this let thing, what is this? This is a bit like apply that you saw earlier. It's an extension function that applies to any, that can be used with any expression. And it takes this, and it just basically takes this expression and renames it to a variable that we can then use multiple times. Okay, so it here is calculated once, and then we can compare it twice. Okay, simple. Like, as always, if I hold down the command key on my keyboard, then I get a hyperlink which I can click to see what this actually does. Okay, so we've got sort of our disambiguation there. What happens if we run our tests? Good, it works. Are there any questions about the code we've written so far? And you know what? Just while I'm waiting in case anyone submits any questions, I just want to show you one thing, which is what happens if you try and debug lazy code? Of course, it's not quite normal Kotlin code because we're using these lazy sequences. If we step through here, you can see IntelliJ is printing things here. You can see that queried is not a list, it's actually an object which is waiting to become some sort of list. Now, this can make debugging such code kind of annoying, right? Because you don't actually see anything here. If we expand what's inside this, then we've got a sequence which is a pointer to another sequence, and we've got a transformer, which is a function. And if we expand that, we've got a progression which hasn't yielded anything either. But that's very easy to fix. You can force a eager evaluation by just saying, give me a list. Like that, and there it is, we can see. Obviously, you wouldn't do this if it was truly an infinite sequence. Then you would, I don't know what would happen. Presumably, you would lock up the ID or you'd get an exception or something. But for the way we're using laziness here, which is just to avoid, searching this potentially large data set, it works okay. All right. Any questions so far, Hadi?
Nope, we're all good.
Nope,
all good.
Okay, well, let's go back to the UI and let's do a little bit of last minute wiring in a very simple way, and then we'll see if the app works. JavaFX has this notion of an observable property. Again, we can add a listener here, and then what we're going to do is say items set all. We're going to replace complete edit text. Now, of course, this doesn't compile because we haven't actually loaded any data. So let's do that now. This is the first bit where we're going to introduce some truly mutable state. Right, we're going to get a little bit imperative here because we've got to load this, going to load this full of data, and then we'll use it later. We could think of this as being immutable, but we'll see why it's not going to be quite like that in a second. Let's introduce a new method called load. Now, what we're going to do here is load that file you saw earlier, and we're going to do this also in a somewhat functional way using lazy code. Java 8 has its own framework for doing lazy sequences and lazy computations. Actually, what Kotlin calls a sequence, Java 8 calls a stream. And the reason for the duplication is that Kotlin targets Android, which does not have all the new stuff added in Java 8. And so, because this is such a generally useful sort of way of programming, Kotlin has its own standard library. But the Java 8 version is actually more powerful. So what we're going to do here is we're going to get a path object. I typed var without meaning to, and you can see that when I did a mutable variable, because Kotlin tries to discourage this, it's actually underlined so they stand out visually a little bit more. But by changing that to an immutable variable, or an immutable value, I should say, that underline goes away. And then what we're going to do is say, give me all the lines of this, and this is a stream. If we put up the documentation here, you can see this is a Java util stream, which is the the lazy stream. So we're going to be decoding and loading lines only when we request them, and then we're going to do a for each over them. Right? We're not using a regular for statement here because a for each is not quite the same thing as a regular for statement. You can see there's actually two forms. There's for each and there's for each ordered. And if we check the documentation, we see an interesting thing. It says the behavior of this operation is explicitly non-deterministic. For parallel stream pipelines, this does not guarantee to respect the order of the stream. So this code, it might not actually load the lines in order. Well, I mean, in this case, it probably will because we are not using parallelism. But when we do, which we'll do in a second, we might get the lines in any order at all. But that's fine because we're inserting them into a sorted data structure so that the order we load them in doesn't matter that much. So let's rename the argument to be a bit clearer. This is a tab separated file. Oops. Sorry. We want to get rid of the tabs. The first field, of course, is the frequency. And then we want to make it lowercase. The frequency is the substring before the first tab. And we'll cast that to an integer. Finally, we'll make our NGram out of the words in the frequency, and we'll insert them into set. Now, one of the useful things about writing code in a functional way is that it's easy to parallelize and get performance benefits. Early research into functional languages thought that maybe compilers could do this automatically, and that sort of has never really happened because it's quite difficult for the computer to guess when performance will improve and when it will not as a result of parallelization. And in fact, not only is it hard for compilers to guess that, it's also hard for people. So let's do a little bit of measurement here and find out if it really is faster or not. Kotlin has this really useful little utility in the standard library called measure time millis. So here we're going to measure the time it takes to execute this code block. And then we'll say, we'll just prepare a bit for this later, loaded file in t milliseconds. Okay. And then we're loading before the UI appears, so let's see what happens. Oops, yes, just rerun the unit tests, but what I really want to do is run this. 2, 3, it's kind of slow. There we go, 4 seconds. And now, there we go, it works. It's sticky, doesn't work well, but it does work. Okay, great. Yep, there we go, you see, and there's actually a bug in Java effects that for some reason I haven't tracked down. It doesn't seem to affect anything, but that's trying to index negatively when you press command backspace on a Mac. But it does work. Okay, let's see if we can make things start up any faster. This was about 4 seconds, which isn't great. Now, parallelizing this for each is super, super easy with the Java 8 streams framework. That's all it takes. We just call parallel on the stream returned from the lines method, and then we do a for each, and this will suddenly magically run in parallel. But of course, It's not safe. We've got a shared mutable state in this ngrams list, and there are a bunch of ways to fix that. Right? Simplest is to synchronize on it. Right? This is the classic lock-based programming way of doing things that will work, but we'll lose most of the performance advantages because only some of the work is this, and a big chunk of it is actually that. So let's see if we can do any better. If we don't have any explicit locking, but we change this to be a utility from the Java standard library called the concurrent skip list set. This class gives us something very interesting. It gives us a sorted set, which is completely thread safe. We can read and write to it concurrently and experience no crashes. It will work. This, you might wonder, why is that not the default? Well, it doesn't come for free. This functionality is very nice, but it does result in slightly slower code. So whether it's actually faster or slower depends a lot on your specific computer, how many cores you have, your data access patterns, your kind of data, things like that. Well, now we've parallelized this loop and we've switched to a thread-safe data structure. Now let's see if it gets any faster. Maybe it does, maybe it doesn't. Depends on a lot of things. Yeah, 2.3 seconds, down from about 4. Right? That's actually not so bad. We nearly doubled the performance based on doing very little. Right, 2.5 seconds could be faster, but that's still over 1 million lines a second. And if I had more cores, it potentially could get even faster. Or if I was doing more work up here to pre-process the text. Okay, so that's fine, and that works. But there are some additional features that might be nice to have. For example, it might be nice if the stickiness that you saw in the user interface went away. Right? When I was typing, sometimes the UI would freeze because it was doing a really big query, and it just stopped responding for a moment. It'd be nice to fix that by doing the query on a background thread, perhaps. Maybe we don't want to do a query on every single key press, but we want to wait until the users stop typing. That'd be a nice feature to have. We probably shouldn't do a query for the empty string because that just yields every string in our database, and that's not really helpful. So we've got all these things, and we could implement all that in an imperative way, and it would work. Yep.
Sorry, Mike, there is one question that's just popped up.
Okay.
Robson's asking why not use map?
Where? Here?
Yeah, I'm guessing there. He's referring.
Yeah, I mean, that would map the lines to a set of ngrams, but we would still have to insert them all into the sorted set, right? Which is actually part of the, a big chunk of the computation time. But he's right. This could be a map, and then we could take the result, all the ngram objects, and then add them to the set. It would generate a bit more garbage, I think. He's right, though, that this is actually not entirely functional, right? Because we're actually mutating this this shared piece of state in an imperative way. It's purely for performance and simplicity. I'm not dogmatic about functional style. I've seen code bases actually get worse and more complicated when they're made functional, so you've got to be a little bit judicious about how you use it. All right, so let's try and apply. So we gave a list of features that would be nice to have in this little app. And we could implement all that in a classical way with some variables and stuff. Another thing that would be nice to have is we'd like to load the words on a background thread so the user can start typing even before we've loaded the database, and then when they will catch up once it's loaded. So we could implement all those features, but it would get a bit hairy. So let's try and apply functional programming principles to user interface code. And traditionally, this has been rather awkward to do because user interfaces are the classical example of massive piles of shared mutable states, and you can't really derive a replacement UI from the previous UI every time the user hits a key press because it would be too slow. So UI code is almost always a mix or entirely imperative. But using a framework called ReactFX and a paradigm called reactive programming, we can get some of the benefits of doing things in this way. So what we're going to have here is what's called an event stream. This is a bit confusing because the same terminology is being reused over and over again. An event stream is not a lazy sequence in the way it was down here. An event stream is a sort of, you can imagine this being like a pipeline of events. And those pipelines can be joined together. You can split, you can rejoin, you can add valves and all kinds of things. And this is what reactive programming is all about. So let's give an example. We're going to start with a stream of strings coming from the edit box. And then we're going to perform a map over that string, over that stream. So again, this is like a functional map. A function is applied to everything which comes down the stream. Oops, sorry, complete it. What we get out of this is a stream of lists, right? And what we want to do is take the completions. We actually, for the user interface, JavaFX wants not a regular Java list, which is what we're getting out of our API, but it wants what's called an observable list. We're not going to use the observability features in this, but we need one anyway. So now we've got a stream of observable lists coming down the pipeline. And finally, we only want actually the last one, because we're only showing one thing at once in our user interface. So we're going to say, starting from the empty observable list, we've got this binding, and this is more JavaFX terminology. What we can do here then is say, we've got the list, we've got the items property, bind it to the last result. And this connects the items in the list to the output of like the last thing that popped off this pipeline of stuff, basically. So, okay, if we run this, then it should work. We have, in fact, not improved the code, have we? This is actually more complicated than the classical imperative style was, but we've paid a little bit of a price up front, probably in performance as well, although I couldn't see it just there. But we have now got a whole lot of functionality that we can use to implement those features really nicely. So first of all, let's say we're going to take, let's say that feature we wanted where we're going to only do a search when the user has stopped typing. Well, this is really easy in ReactFX. All we have to do is specify this time. Actually, let's make that really obvious. Let's say half a second here. And what it will do is it will buffer up the things coming down this pipeline until 500 milliseconds has passed, and then it'll allow the last one onwards. So this does exactly what we want. Yep. Oh, no, wait, it doesn't yet, because as we can see, I forgot to, there we go, I made a little pipeline that didn't go anywhere. If I join things up again, then we should be able to see it much better. There we go. We can see now that it's only doing that after we type. So we've got fewer edits. That was a pretty nice thing. One line of code, and we've got that feature we wanted. What about getting rid of the empty query? The empty query is by far the slowest because it tries to load everything into that list. Well, okay. Now, when we do backspace and get rid of all the text, nothing changes. We've still got the previous things we typed in. That's pretty nice. Again, that was pretty easy. We just did a functional filter over that pipeline. Final thing, it'd be really nice if we could do the completions in a background thread and just get rid of that last bit of stickiness, especially because as we crank this down, we get more responsiveness, but the UI gets stickier because we're doing all the computations on the user interface thread. So we're blocking re-rendering. And ReactFX makes that super easy as well. Let's take the fewer edits stream. And you know what? First of all, we need to define our background thread. So let's give ourselves a background thread. And then let's say thread bridge. So we're actually moving the events now into the background thread where we will do the completions. And then we'll take them back onto the user interface thread where we're synchronized with drawing. And we can get it back. And now let's try it. Oh, no, I've done it again. I forgot to join things up. There we go. Let's get rid of that. Let's try again. Yeah, there we go. And now the last stickiness is gone. I can type as fast as I want. And it's doing exactly what I wanted it to do. Now, you notice actually I introduced a bug here. These things aren't quitting because of the background thread. Yeah, you know what? Rather than have to worry about all the daemon threads and stuff, just because this is a demo, it's not very clean, but I'll just force the VM to quit there, and that will get rid of these hanging processes. Okay, one last thing. Let's make this load in the background. That would be nice. To do this, we're going to have the problem that if we're doing loads in the background, then as a user types, they might get incomplete results, which would be really annoying. So what we want to do is, whilst we're loading, allow the user to type and then catch up as soon as we finish loading. So to do that, what I'm going to do is use this nice library called Kovenant, which is a promises library specifically designed for Kotlin. And it just allows me to say, okay, let's do this in the background on some thread. It'll actually be a different thread to this one up here, but that doesn't matter. We'll, and then once this code is done, go back onto the user interface thread, and we can use the results. So, oh yes, and then I have to remember to run configure Kovenant at the start. Okay, that makes it work with JavaFX. Now, what we want to do, and again, this is a point where reactive programming and this whole streams of events paradigm becomes really helpful. What we want to do is have this stream buffer things up in such a way that we can pause it and then restart it later. And we want to start out paused. Actually, if we ever wonder what the type is, we can easily ask IntelliJ to show us. This is a suspendable event stream, which means that we can actually ask it to suspend itself. And the forgetful one, there's several types of suspendable event stream, and forgetful returns to the stream that when suspended forgets all but the latest event. The remembered event, if any, is emitted from the return stream upon resume. Oh, that's great. That means as we get these edits, we get the users typings coming down the stream, we can just buffer them up, and then the moment we've finished loading, we can resume the stream and everything will work correctly. So let's do that here. Boom. And there we go. And I was able to type even before it finished loading. And then the moment it finished, I had all of the completions available to me. Great. All right. So let's see. It's 4:45 already. There's one last thing I want to show you, which doesn't, I'm afraid, fit. I wasn't able to find a way of fitting it into this example app, but I wanted to show it to you anyway. And that's a few bits of functionality from a library called funKTionale by Mario Aras. And funKTionale adds a few features which are normally only found in languages like Haskell. But because Kotlin is carefully designed such that libraries can effectively extend the language, but without very complex approaches like compiler plugins or macros, it's actually possible to implement some of the more curious features of these languages entirely in a library. So this is an example of, I'm going to have to manually add the import here because I auto-typed this stuff. Gosh, what's the, there we go. And we'll take currying as well. So functional languages have a couple of features called partials and partial application and function currying. And there are ways that you can take functions and break them apart, or sticky bits. So here we're defining a simple function, right? This is a lambda and we're assigning it to a variable here, a value, sorry. And all it does is it takes 3 strings and glues them together. Dead simple. Doesn't get simpler than that. What we can do here is, using the funKTionale partial applications library, is generate a new function which has the 3rd parameter fixed. So now this function, if we specify that type explicitly, you can see it's actually only got 2 arguments now instead of 3. We've fixed the 3rd one. And then finally, we do it again. We can fix the 1st one, and this will pass. This assert will pass because it will be glued together. Now, this can be very useful if you have a very repetitive set of uses of a function with many arguments. Something you can also do is what's called function currying. And this is named after a guy. The reason it's called function currying is the guy who came up with this concept. His last name was actually Curry, so it's named after the guy. And what this does is breaks a function apart so that each argument is itself like a subfunction. And this is a bit hard to explain in English, but it's easier if I show you. If you've ever looked at Haskell code, you will have seen code that looks like this with a little arrow. And in fact, that's how you write functions in Haskell. And what this means is you can do something like that. You call a single argument, a second argument, and then what you've got here is a final function that takes a string and returns another string, right? So it's doing something similar to partial application, but specifying things one function at a time. And you can actually do the reverse. You can uncurry as well. Like I said, these things can be sometimes occasionally useful. I don't actually tend to use them much in my own code, and I couldn't find anything in this program that would benefit from them. But it's there if you want them, and especially if you're familiar with Haskell and you're looking for something that has some similar features but runs on the JVM, then you might find that stuff interesting. All right, thank you very much. That is the end of my tutorial. I think we've been talking for about, I don't know, 40 minutes, 45 minutes, something like that now. So if there are any questions, then now is the time to ask.
Great, thanks, Mike. There are a couple of questions. There is one by Dennis that was asking that I think the RX would be useful in this case. I'm guessing, I don't know when he actually asked it, but there are.
Yeah, I don't know when he asked that, but yeah, React FX, which is where this comes from, is essentially the RX sort of
adapter for
style of programming. It's not based on RX, but it's based on that style of programming, and it's a separate standalone library for Java FX for GUI programming specifically, but it's pretty complete. You can see if we go back to this, if you look at all the methods that are available here, all the things you can do to these pipelines, you've got a full toolkit here for plumbing stuff basically, and it's a pretty nice framework.
Yeah. Then there is one question from Volchik back when we were talking about the map. He just said if it would be possible for you to quickly just convert that to map to see what the impact on the performance would be.
Was he referring to this for each here?
Yeah. I don't know if you want to do that now, or if you can actually make the code of the webinar, if you're going to make it available. I guess that would be a good exercise for people to try themselves.
Yeah, I can put this on GitHub afterwards, actually. That's fine. That might be easy. Yeah, to convert this to a map, I mean, again, I'm not sure there's any point. You don't want to just, use map and filter and reduce for everything just for the sake of it. But if you did, then you would end up with a list of NGram objects here, and then you would use add all to the result. So it's actually pretty easy to do that. You would just do that. Let's not define the thing, and then you would just do that. But where's it's not happy? I say it's so simple, and then actually, yes, because I'm still using for each here. That's why. And then because this is Java, which is a bit annoying, you have to say you want to collect it into a list, and yes, right. And then what it wants is there's a Kotlin type safety issue here, which I would have to figure out. We've got two types of lists, and it's not happy because one's a collection and one's a mutable list here. Probably if we do something like that, the problem will go away. No, okay. I would have to look into why it's not happy with this. The Java 8 type, the Java 8 framework is a bit harder to work with than the Kotlin one, but it does have more features.
Okay, and I think just one last question is, in terms of usage of React FX, the question is using thread bridge to FX twice right, or does it have to be thread bridge from FX and thread bridge to FX?
In fact, you are correct. That is a bug. That should be like that. Because yes, that's correct. That should be from and then to. Yeah, that's something that would probably have not worked very well.
Okay, great. So let me just switch over a second. 1 second.
There we go.
Thank you.
Any other questions?
No, I think that's it. So just want to say thank you very much.
How to use IDEA. Sorry, there's just one last question I saw in the window.
Sorry,
the shortcut is Alt-Enter to bring up the intentions list. So if I press Alt-Enter, then I can say specify type explicitly, like that.
Oh.
And then I can just undo that. There's also there are other hotkeys to do that, but that's how I do it. I just use the intentions, which are really useful. Alt-Enter to bring them up. Okay, I'm done. Sorry, Hedy.
Cool. No worries. Thanks. Once again, I just wanted to say thank you so much for the webinar. It was really great. So we will make the recording available. And Mike, if you could just give us the link to the GitHub, if you do push it to GitHub, I think people would love to explore the code a little bit. It really did highlight,
Sure.
I think, two aspects of Kotlin. One of them, one aspect was the constant use of higher order functions, and the other one was how easy it is to seamlessly kind of extend the language with your own.
Yeah, absolutely. Yeah.
So once again, thanks for that. If you guys have any feedback on the actual webinar, please feel free to contact myself or Robert Demmer. Those are Twitter handles. And Robert's email address is robertdemmer@jetbrains.com, who handles all the webinar organizations for us, among other things. To learn more about Kotlin, you know where it is, kotlinlang.org, and follow us on Twitter on &Kotlin. Once again, Mike, thank you very much for the webinar.
Thank you, guys. Thank you for listening.
Bye-bye.